Okay, so for the following, we have to find VO of t, and we have to use Laplace for this. So let's start off by getting the Laplace transformation of e to the power of minus 2t times the unit step function. So we see the one that matches with this one is this one. So uc of t is equal to u t minus c, and then we have f t minus c. And if you take the Laplace of that, you get e to the power of minus cs times f of s. So we see here our c is 0. So that means this is just going to be 0. So this whole thing will be times by 1. So we have to find our f of s. And we're going to find that using this. So this is going to belong to here. So we have to find the Laplace of e to the power of minus 2t. And we can use that for in here. So we see our a is equal to minus 2. So Laplace will be 1 over s minus a, which is minus 2. So it'll be 1 over s plus 2. Okay, so we'll pretty much ignore this. So it'll be 30 over s plus 2. Okay, let me erase all of this. Now, the Laplace of the resistors are just, the regular values. For the inductor, it's pretty much SL, so 2s. Alright, now we see here, we're trying to solve for this. We know this is the ground here, so 0 volts, so that means VO of t will be this whole node here. So we can do a node analysis. So we'll let a current moving in this direction, a current moving here, and we'll let a current moving here as well. So let's start solving. So for node VO of t, it's VO of t minus 30 over s plus 2 all over 1 ohm. And plus, oh, so it's not VO of t, it's VOS. Sorry, my bad. It's supposed to be, because everything's in Laplace format right now. So it'll be VOS over 2s plus VOS all over 2. Okay? So this is to the all over 1, so we can just ignore that. Let's factor the VOS. And let's bring this to the other side. Okay? So let's get a like term of 2s. So we'll times this one by 2s. And let's times this by just s. So it'll be 2s plus 1 plus s all over 2s. Okay, and then this is just 3s plus 1. So what we're gonna do next is pretty much divide everything by this, or we can just do times everything by 2s. So this cancels out. So this turns into 60s, and divide by 3s plus 1. Okay, next I'm gonna factor out this 3. So it'll be 1 over 3, and there'll be a 3 out here. 60 over 3, that's just 20. And now we're gonna get the inverse Laplace of all of this. So this turns into VO of t, and we just have to find the inverse Laplace of 20s all over s plus 1 over 3 times s plus 2. And we can do this using partial fractions. So let's do that. So 20s all over s plus 1 over 3 times s plus 2. That's equal to a all over s plus 1 over 3 plus b all over s plus 2. And then times everything by this. So we have 20s equals a times s plus 2 plus b times s plus 1 over 3. When s is equal to minus 1 over 3, our a is equal to minus 4. And when s is equal to minus 2, our b is equal to 24. So it's going to be minus 4 over s plus 1 over 3 plus 24 all over s plus 2. Now we just have to find the inverse Laplace of each of these. So we can do minus 4 inverse Laplace of s of 1 over s plus 1 over 3 plus 24 inverse Laplace of 1 over s plus 2. Okay, and after you use your Laplace transformation sheet, you should get the following answer. And this will be your VO of t for when t is greater than or equal to 0.